Good morning to everybody. We have started our mass transfer course. In last lecture, we discussed about the study materials, what are the books we should follow to learn this course. Thereafter, we discuss about the course evaluation and we discuss about the course structure. And in mass transfer, we will study 6 chapters, and in mass transfer 2, we will study another 6 chapters in the next semester. So, let's start with the introduction and motivation of this course, the first chapter. So, if I ask you, you study mass transfer course, then automatically the question will come in your mind that what is mass transfer or what is separation process. Then definitely we will ask question within ourselves, why should I study this course as a chemical engineer? What is the profit after learning this course? Definitely this type of question will come in our mind. Not only this course, if you for any courses, but not only course, any things, new things, once people will force you to learn this one, then definitely these types of question will come on our mind. And let's try to find out the answer of these questions with a few real-time examples. So let's start with the first question, that is, what is mass transfer or separation processes? Answer is very simple. So mass transfer separation process is a technique that transforms a mixture of substances into 2 or more products. That's mean if you have a multiple components, multiple type of components in a mixture, then you need to separate them as per market demand. As a chemical engineer, we need to separate this, and mass transfer course will help you how to separate these things. Okay. So already we have taken few examples. Just again, I am just repeating these examples, that separation of gold from its ore. Okay. So now another example is separation of ethanol and water from its mixture. If you have a mixture of ethanol and water, and you need to separate ethanol, then in our body also separation process is going on. Our lungs are separating oxygen from air. So air is a mixture of mainly nitrogen, oxygen, carbon dioxide and other small things, and our lungs is separating oxygen from the air and transforming into the blood. So in our body, also the separation process of mass transfer is going on. Okay. Now, second question is, why should I study this course? Okay. Now, before that, I will ask you one question: what are the essential needs of our society? What will be your answer? You may tell, okay, sir, mobile, internet, this type of questions. But see, what are the essential needs of our society? First one is energy. You cannot move a single step without energy. Okay, without electricity you cannot move. Without petrol or diesel you cannot move. Okay. Then second thing is agriculture sector. If you don't have agriculture, you will not get food. So that is essential to survive ourselves. These sectors are required: energy sector, agriculture sector, then healthcare sector. You understand? When we will be ill, then healthcare sector is very important. Then our daily life commodities. Okay, table, chair, pen, paper, whatever the things are in daily life, 100 of products we are using in daily life. These are our essentials. And lastly, the environmental issues, because we have to keep our environment safe. If we cannot keep our environment safe, we will not be here for longer time. Nowadays, and in Delhi the pollution is so high and it is headache for us. Okay, so these are the 5 things are required in our daily life, otherwise we cannot survive. Now, what are the role of separation processes in these sectors? Okay, let's take the energy example. I will give few examples in each sector, and where you will see that how separation process is important. Okay, now if you see the sources of energy, okay, natural gas, petroleum, crude, coal, then solar, wind, tidal energy, biofuels, ethanol, butanol, then another is nuclear energy also is coming. Now among these I will give 3 examples. One is from natural gas, another is from petroleum crude, and another is from ethanol, biofuel. Okay, so now let's see the natural gas. So natural gas, it contains methane, carbon dioxide and H2S. In last lecture also we discussed this thing. So we need to remove H2S and carbon dioxide before sending it to the CNG station or power plant or fertilizer plant, wherever it is, because these are the unwanted things. You can see this video, I have given this link. Okay, you can see how the natural gas we are taking from this one. Okay, but keep it in the thing, all are gases: hydrogen, H2S, carbon dioxide and methane. Now question will be asked to you, you do this job, means you separate methane from the mixture of H2S, carbon dioxide and methane economically. That word is very important, means you have to develop one separation process which is cheap. Okay, otherwise cost of CNG will be high, nobody will buy this. So you have to make this job but economically. Now after study this course, you will be able to remove H2S and carbon dioxide selectively from natural gas, and also you will be able to design the corresponding equipments. Now if you take the second energy sector, that is petroleum crude. Okay, so in petroleum crude, this is a picture of a particular in a refinery. In petroleum crude is processed in a refineries. In India we have number of refineries: Haldia refineries, Panipat refineries, Dibrugarh refineries. There are number of refineries are there. Okay, then Reliance also has a refinery. But if you see, there are the tallest tower, that is the one separation unit, one that is called atmospheric distillation unit, and beside there will be one little bit small, that is the vacuum distillation. You can see the YouTube to get its more knowledge. Now if you look at this petroleum refinery shape plant little bit deeper way, okay, then this is a crude petroleum, okay, crude oil. This is a thick slurry, lot of sands and other heavy metals are there because it is coming from the well. Then there is a desalter. There is one equipment that is also separation equipment. Desalter is there, so they are separating the heavy metals and sand and other things. Then the liquid part that is coming here. Now this liquid part is heated here to around its boiling point, and then they are putting this thing in this separation equipment one, which is called atmospheric distillation. And from this atmospheric distillation you will get the LPG, okay, then you will get the naphtha, what we call the petrol, okay, and this heavy and light naphtha is the feedstock for the petrochemical industry. See, this is the petroleum industry, and from which is the product of the petroleum industry, that is the feedstock for the petrochemical industry. That also we'll see one example, okay. So but keep this in mind, naphtha is the feedstock for the petrochemical industry. Then kerosene, light gas oil, heavy gas oil, sometimes this is called aviation turbine fuel, okay. Then diesel. From this is atmosphere. Then whatever the residue part, they are putting in another separation unit, that is in vacuum, that is called vacuum distillation unit, and from there we are getting the different kind of lubricating oils, okay, and finally vacuum residue, okay, pitch, bitumen, all these things. So these are we are in petroleum industry, from crude to these are the products. We are separating this. These are multiple type of products. Now question will be asked, which separation unit you want to make for this one and which separation unit for this one, and what will be its size, what will be its length, what will be its diameter, what will be its internal arrangement, whether it will be packed bed or tray column, how will it be. But when you will study this mass transfer course, then you will be able to design this separation unit for the fractionation of petroleum crude. Okay, let's take another example, the ethanol. Do you know what is ethanol? Why nowadays ethanol is a very demanding chemical. Why do you know? Because this can replace the petrol. In USA 30% ethanol blend is there with this petrol, and India even there is 10% blending is there. Now why government is forcing to blend ethanol with the petrol? Because this ethanol is renewable. Renewable means, if you see, it is getting ethanol is getting produced from corn. Then it is food competitive. It was, now people are not using. Now people are using corn stubble or any waste agriculture biomass. Waste agriculture means, what is this composition? Hydrocarbon, hydrogen, carbon, main small amount of oxygen and other things. So from this we can produce the ethanol, and corn stubble agriculture or whatever the waste biomass, sometimes it is called lignocellulosic biomass. It is renewable. You can understand, even in our NIT Agartala campus, how much this waste biomasses are available, and if you will be surprised, there will be a number of around 50 gardeners are there. They are cutting the grasses and throwing. waste. And these are the potential feedstock for the production of ethanol. Now, how will you do this? There is a milling, you should to cut these things, then there is some pre-treatment process and saccharification process, okay, and then there is a fermentation process. Fermentation, there is one organism in there, it will produce the ethanol and water. Now, in market, you need the pure 100% ethanol, no water. So, you need to separate ethanol and water as a market demand. Then, this is the separation unit is required. Now, question will be what separation unit I will go, whether pack bed or tray tower or other things, and definitely what will be the size, all these things. So, and that you can able to do when after studying this course. You will be able to design the separation equipments for the separation of water and ethanol after studying this course. Okay, so I have taken 3 examples for the energy sector. Let's take few examples in agriculture sector. In agriculture sector, what are the most important things? One is fertilizer. Generally, it is called NPK fertilizer, nitrogen, phosphorus, potassium. Okay, if you give this thing, then plant will grow. Okay. Now, nitrogen, the source of nitrogen, and generally urea is widely accepted as a nitrogen source. And phosphorus source is diammonium phosphate. Actually in DAP both ammonia and phosphate, nitrogen phosphate is there, but here phosphate is main, ammonia is. And potassium, that is actually ore. Generally we import this ore, okay, and we spread in our field. That cannot be produced. That is the ore, potassium. So we can produce the urea and diammonium phosphate as a nitrogen source and phosphorus source. And if you see now what is the chemical formula of urea? CONH2 whole 2. Okay, and DAP diammonium phosphate. Okay, and you have seen this if you some people maybe know, because I have experience, I asked in the class, have you seen urea or DAP? Some people told no, but some people notice it. But if you don't see, please go any that agriculture shop near to your thing, but not during lockdown. When it will be, then you will see how it is. This is the marketed product. Small white granules, urea, and this gray color granules is diammonium phosphate. Now, how urea is making? So, urea, this is the urea, and how it is getting produced? 2 molecules of ammonia and 1 molecule of carbon dioxide, and with this reaction you will get the urea. Okay. So now how will you get a carbon dioxide ammonia? So ammonia I will get from nitrogen and hydrogen ammonia. Then how will you get hydrogen and nitrogen? First let's take how will you get nitrogen. Nitrogen I will get from air, because almost 79% nitrogen is there in the air. So this is the source. And hydrogen and carbon dioxide, how will you get? The source is hydrocarbon. Either you can use naphtha or CNG. Okay, this is hydrocarbon source. It is the petroleum product, one of the petroleum cut you have to use, or natural gas also you can use. Okay. Now hydrocarbon means mainly hydrogen and carbon is there. So there is some procedure, some first sulfur removal, then there is a steam catalytic reforming reaction, okay, and therefore they mix there is a shift conversion. After shift conversion, okay, the product will be mixture of carbon dioxide, nitrogen and hydrogen. Okay, so nitrogen hydrogen will make the ammonia, then ammonia plus carbon dioxide will give the product urea. But here problem is to produce the ammonia from nitrogen and hydrogen, carbon dioxide has to be removed. Why? Because in this reaction, the reaction condition is pressure is 150 to 200 atmosphere, temperature 450 500, and catalyst is activated iron. Now if carbon dioxide present trace amount in ppm level, even carbon dioxide present in this mixture, then it will poison the catalyst. So there won't be any ammonia formation. So you have to remove the carbon dioxide completely. Not only removal, if you remove first, then let it go this, okay, then remove this one, then carbon dioxide, then you make the ammonia synthesis, then ammonia, then you need again carbon dioxide. That means again you have to reproduce this one. That means you have to separate this as a pure product, because later this I will use this as a, because you will for produce urea only ammonia and urea carbon dioxide also require, which already I have made in this reaction. So I have to use this one. So my job is first you remove the carbon dioxide from the mixture of carbon dioxide, nitrogen, H2, then it will come the nitrogen, hydrogen, then you produce ammonia, then with this ammonia you use the carbon dioxide from that. Now question will come, how will we separate the carbon dioxide from the mixture of nitrogen, hydrogen? Complete removal is required. That is nothing but a separation. You need to separate carbon dioxide from the mixture of carbon dioxide, nitrogen, hydrogen, and all are gases. That is the very important thing. Okay. So it is very challenging, but when you will study this course, then you will see it is possible to separate. And for that one, you need the fundamental knowledge of mass transfer. Okay. Then again, when urea is formed from the reactor, that is semi-solid or slurry, and our final product is this granules white. So how will you make this granules which is marketable product? Now, if let's say one company is producing this very good white and very good granules, and if you produce the dust ammonia, okay, dust urea to your market, nobody will buy from you. So it is very important to make whatever the market demand is required, you have to satisfy the customers. So now how will you make this? Okay, and I already told it is possible through the drying process, and which is nothing but a removal of moisture from this solid. Okay, and then which equipment should I use? Okay, it may not be which equipment I am separating carbon dioxide from the mixture of carbon dioxide, nitrogen, hydrogen. Same equipment I cannot use here. Then what equipment should I use? Okay, so you will be able to get answer of this question after studying this course. Then now let's take another example, that is penicillin. That is healthcare sector. There are a number of examples, but I will give one. Okay, penicillin. Do you know what is penicillin? Penicillin is an antibiotic. There are so many functions are there. Okay, and penicillin is a fermented product. Okay, fermentation, and after fermentation you will get the mixture of penicillin and water. Okay, then what your final product is this, that is solid. Then you have to remove penicillin from the water. That means you have to separate water and penicillin. Now how will you separate this thing, and which equipment should you use? Okay, and definitely you will be able to do it after completing this. Now let's take the other third thing, fourth thing is daily life commodities. No, and I have given the example of petrochemical industry, and I told you already that what is the feedstock of the petrochemical industry is generally naphtha, which is the product of a petroleum refinery, or sometimes it is natural gas. Okay, so if you take this is the oil and gas, okay, then petroleum refining, then petrochemical industry start from here. Okay, then they will produce the olefins and aromatics, and olefins are generally ethylene, propylene, butadiene or butylene. Aromatic is BTX, benzene, toluene, xylene. These are called the platform chemicals. Means from these only 6-7 chemicals you can produce number of final products. The olefins, ethylene, propylene, butylene, you can produce polypropylene, polyethylene, butadiene, polymers. Then you can make electronics, furniture, packaging, piping, all these things. Intermediate fibers, textile. Okay, textile, you can understand the, in our shirt we are using, that is some textile is there. And we know as a chemical engineer, you know number of chemicals that we are producing, and that chemicals are using, we are using in pharma company, our healthcare sector, paint, fertilizer, detergent, everywhere we are using this thing. Okay, now if you see, so the thing is that the studying is crude oil, petroleum refinery, then petrochemical industry. Okay, the petrochemical will give this thing, and from there you will get the marketable product. So chain is this, all are the value added products, so we cannot ignore the petrochemical industry. Now let's see little bit deeper sense, and this is the all consumption of primary petrochemicals in 2008. See, ethylene and propylene, this is around 60%. Okay, then benzene, toluene, xylene, ethanol, butadiene. Okay, so only 1, 2, 3, 4, 5, 6, 7. So 7 chemicals are primary chemical. Okay, from there you can produce number of products. Okay, and one consumption is highest, ethylene and propylene is more than around 60%, and benzene, toluene, xylene also important, is around 30-40%. Okay, now let's see the schematic of petrochemical industry. Now before that, let's see that just for in this ethylene and propylene, what are the end products. Okay, so let's see. Ethylene, you can produce polyethylene, ethanol, ethylene oxide, vinyl acetate, 1,2-dichloroethane, and from there some intermediate. Ultimately you can produce the engine coolant, polyester, or polyvinyl chloride, PVC pipe, you know this one. Similarly for propylene, isopropyl alcohol, acrylonitrile, polypropylene, polypropylene oxide, acrylic acid, allyl chloride. these things are interpolated, and final products are polyol, propylene glycol, glycol ethers, epoxy resin, all these things. Okay, so that's why only these 8 chemicals, these are for platform chemicals or primary chemicals, which are produced in petrochemical industry from the naphtha. Okay, naphtha is the feedstock and product is these 8 chemicals, and from these 8 chemicals we can produce number of our daily life commodities. Now let's see what is the schematic of petrochemical. So if you take the crude oil, petroleum refinery, general naphtha, ethanol, gas oil, these are coming from the petroleum refinery, and these are the feedstock in your petrochemical industry, that is the steam cracker. Okay, and you can use also natural gas. From natural gas you will get the methane. Okay, then there will be small amount of ethane, propane, butane, generally it is present, you can put this one. Even methane also you can put in this thing. And this is the reactor. From reactor you will get the mixture of ethylene, propylene, benzene, butadiene and some other products. And from petroleum refinery you will get directly benzene, toluene, xylene. Okay, so you got this benzene, toluene, xylene from the petroleum refinery industry directly. Okay, but in petrochemical industry there is a reactor. Okay, from the reactor you are getting 7, 6, 5, 6 or more than 6 products. Then you need to separate them. You understand ethylene and propylene, only one carbon difference is there, very close. Okay, and now how will we make this separation? Because you need the 100% propylene, 100% ethylene, 100% benzene. So this separation process you can do this after studying this course. Okay, now if you take the last one, that is environmental issues. Okay, so in environmental issue, you know, in any chemical industry there is an environmental regulation is there. Okay, any chemical industry, because generally chemical industry produce lot of waste, effluent, which is harmful for us. If they, let's say, some gaseous from the, if you see the industry, there is on chimneys there, and some smoke is coming out. Now with this smoke, if this smoke, if ammonia is 2%, then it will be very carcinogenic. So industry, from the industry there is they can leave this on, but but our government will not allow them to leave that much of ammonia. They can tell, okay, you can that in smoke some ammonia can be there, but this should not be greater than 100 ppm. So that's why there is environmental protection agency is there in government sector. They will tell you have to remove this. That's mean, so to bring down the ammonia from 2% to 100 ppm, you need another separation process. Even sometimes from the industry we throw that water, polluted water, particularly in paper industry, or if you go that Vedanta industry, they used to, whatever the things effluent is coming, they like, but government will not allow them. So there is separation process is required. Here I am giving one example that is very common, that is drinking water problem. And that in India, particularly Bihar, UP, and also in Northeast, so many arsenic, iron, sometimes fluoride also found in underground water. Now, what as a chemical engineer, you have to separate them. You have to separate iron arsenic fluoride. Not only separate with affordable cost, that is very important. People can separate, but cost will be very high. But it is not possible because poor people have to drink water. So how do you separate this? So, and that's now you understand how separation process is important in your society. It may be either energy sector or agriculture sector or healthcare sector or our daily life commodities or environmental sector. In each sector, separation process plays important role. And separation process or master generally if you so taught in chemical engineering discipline. You are the master of separation process. If you go any other discipline, see, they don't know much about the mass transfer and separation. This is the unique opportunity. That is your pattern. I know I can make this. Although I have given only few examples, but there will be thousands of examples in your daily life where separation is required. And once you know once you will study this course, you will be able to make the separation process. Not separation process, you can separate the things as per desired product economically. That is very important word, economically. Okay, and to do this you have to learn this course, and that is the unique opportunity. Okay, because in no other discipline mass transfer is being taught in so deeper way. And so if you see in general, if you take the any chemical industry, I have given number of examples, but if you take the generic, say in a chemical industry there will be sometimes there will be reactor and raw material is there. Okay, just check if raw material is there, you need for sending to the reactor, you need to separate some impurities. In crude oil case, okay, you need to separate the heavy metals. Okay, and after putting this reactor, then products, liquid products will come. But it will not be generally, it will not be single product. You have seen in ethanol fermentation there is water and ethanol. Then you have to separate this. Okay, separation unit is required. And gaseous steam you cannot put in directly to emit into the environment because there is a environmental regulation issue. So you need to separate this. Again, whatever the effluent is coming from your plant, that you cannot effluent, you cannot put directly to the river. You need to separate them. So you can understand how separation processes are important in chemical industry. Without separation, no marketable product will come. Okay. In chemical engineering, two subjects are very important. Core subject, that is mass transfer operation and reaction engineering. And these two subjects you know better than anybody in across any discipline. So these two courses you have to study well. Then you will get only your own identity. And you can see this value. In generally, in chemical industry, separation cost is around 40 to 70%. So if you can minimize the separation cost, then you will add the value. So with this example, now I will ask you a question. Why should we study this course as a chemical engineer? What is the short-term effects? Immediate effect. Not after just passing out or BTech degree, or just before passing out, there are what are the profits. That will be your immediate effect. So I am giving two. One is, all of you want to crack GATE, and in GATE, if you see, 15 to 20 marks will come from this course mass transfer, and you know that if you can crack the GATE, what is will be your future. You will get job in private sector, okay, if you want to do job, or if you want to do higher studies, you will get very good opportunities in premier institute in India like IITs. So immediately that whatever you study this course, that is will come before you completing your fourth year, before your graduation. Then other than this, you will sit in the campus interview, and if you see, if if you as a I am telling is as a chemical engineering profession, means if core company comes, and some core company comes, Reliance come, Vedanta come, some other 2-3 other companies also come. You know what is the feedback from the Reliance? They told, we want to take more, but you know, student does not have that much quality. What we want. And definitely, when they will make the interview, they will ask the question from the mass transfer question. And if you are able to answer this question, you will be absorbed. So then you have a better growth in chemical. Not only after getting job, then also when you will work in an industry, okay, then if you can solve the problem, if you know this course very well, then you will be able to solve the problems in industry better than the other people. Once you can able to, then your professional and management will notice you, and your professional growth will be higher. See, immediate 3-4 years, these are the immediate short-term effects. And what are not long-term effects? You will be able to solve burnings needed by the society. Okay? Because whatever your contribution, either is energy sector or healthcare sector or agriculture sector or environmental sector or daily life communities, ultimately you are solving the burning issue of the society. And not only that, once you learn this course, in your personal life, you will find some problem where you need to separate. Okay, why I am telling this, because I have experienced this. You need to separate and basic knowledge of this thing, then I will able to do this on the spot. Some quick things you will able to do. Okay, so with this thing, we tried to justify two questions. One is, what is mass transfer, and why should I study this course as a chemical engineer, or what is the profit of after studying this. Okay, so these are our conclusions. So we can separation. Without separation process, you cannot run the society. There is a direct contribution to our society, what we can. And finally, these are the short-term measures and long-term measures. Okay, thank you for your attention. Let us stop today. Okay, in next day we'll discuss more about this thing. Thank you.